Hello everyone, welcome back to my channel. Topic that we'll be covering today is normal distribution. It is from paper 2, that is Quant. Though it is from Quant, but the basic understanding is required in paper 4. I mean, it is widely used in paper 4 valuation and risk models. Before we proceed, I would strongly recommend you to subscribe to my channel, like and share with your colleagues if you like the content of the video. So let's kick off the discussion. So this is the flow that I'll stick to when I'll be explaining you the concept of normal distribution. So first we'll understand the concept and we'll see the key properties. Usually the questions that are asked are around this second point only, and demonstration of normal distribution. Basically this is actually needed for you to understand the concept fundamentally. So I have come up with some hypothetical data. You can take real real life data wherein you can just apply the logic that I'll be explaining you here to get more insight of uh, how the data is basically behaving in the real life. So let's move ahead. So the see this normal distribution concept is very important because in not really in finance, but if you observe in any if you collect any data, basically the simplest example that I can give you of if you collect the marks of the students of the class. So say for example, many students would be around 50, which is assuming the paper is of 100 marks. So many people will be around 50. There will be very few people who will score very high, around say 90, 95, 98. And there would be very few people which will score very less, say around 20, 15, 10 marks. So the basically normal, so if we plot this distribution as well, if you recollect in our school days, we used to plot frequency table. And so if you plot that frequency table in this program, so if you will see that that data follows certain pattern that is called as a normal distribution. So that's the key reason in finance also. Usually most of the time market is in a range of average. At instances, it attains extreme values as well during the crisis. Say, for example, during the COVID or subprime crisis, the negative extremes were achieved. And sometimes during elections, positive extremes are achieved. So that's the basic concept of the normal distribution, and that's written over in here in the simple language. And this is a formula that if you need probability of data point at particular point. So this is a formula. I'll demonstrate this when we'll be going through in the Excel. So next is key properties, but even I would like to touch upon Excel worksheet to demonstrate normal distribution in detail, so that I mean these properties would be quite clear to you. So say for example, you have got certain data. So that data is so that is a variable. I mean your variable takes certain values, so that data has been collected. Say for example, this is a very simplest form of the data. I have taken minus 40, minus 39, and till the way till plus 40. So minus 40, I mean at a distance of 1 unit I have collected the data. But in general it could be anything. I mean simplest example I can give you of stock return. So you can collect the stock return for, say for example, 1 year, and you can apply the same logic for what I have applied on this particular thing. So so if this is clear, if I have got variable which is taking value minus 40 on first day, minus 39 on second day, and so on till till 80th day where it takes 40 value, and mean, that is average of this particular data set, is 0 because I have taken minus 40 to plus 40. So eventually it will give you the expected value, average, mean to be 0. And standard deviation, of course, there is a formula, but in Excel it is directly calculated. Why I have calculated this? Because there is a very familiar parameter which is called Z value in normal distribution, which we talk quite frequently. So to give you the more explanation, basically Z value is a number that gives you, say for example, if I have if I have to check this for minus 40 is how many standard deviations away. So this is a key line. So Z value tells you this data point is how many standard deviations away from minus 1.7. So if you multiply this into the standard deviation times, so you get this value. So basically Z gives you the uh, number of standard deviations you are far from your expected value, your average. So Z value for all the data set has been calculated. Formula for Z is this is X minus mean. So distance between your data point and your mean, that is calculated in the column C. So if you divide this distance of data point from mean by the standard deviation, you get your Z value. So this is Z value. And this is a cumulative distribution function, which basically, if you recollect, in our school days, we used to calculate frequency for number of students taking scoring 70 marks is say for example 10, and total number of students are 100. So 10% of the students have scored 70. And likewise for 80, the under 80, it will include 70 also. So when we calculate the probability for 80, 70 is added in the uh, in when you calculate the probability for 80. So this is a cumulative distribution function. When you this is a function that is built in the Excel to calculate cumulative distribution function. And this is a way that I just talked about, which we used to follow in the school days. And at the end, we used to get 100. But this data set is not normally distributed, and we are not getting exact 100% when you're using this function. And uh, this was a cumulative, and this is a probability. Actually, this is a probability of what is the probability of minus 40. So if you see very less, so these are extreme values, minus 40 and plus 40. So these are extreme values. That's why you see probability of this number occurring is very less. Similarly, for plus 40, probability of this occurring, the 40 will be outcome in the data point is 0.4%. And majority of your data lies around the mean. So if you see, uh, there is a very high probability as compared to what we see for 40 for the data set that are around the mean. So this is 0 is our mean, as we had seen here. So this is a probability, and this is a probability calculation using this formula. So if you want to tie back, so what this function in Excel is doing is eventually this formula has been built in the Excel, which is doing this. So these are the cumulative and probability distribution using the Excel function, and these are the columns CDF and PX using the manual formulas. So this is how we plot cumulative distribution function and probability distribution function. And if you see, this particular data set follows a normal distribution. So this is a bell curve, which you might have seen quite frequently. And this demonstrates that this data set is following the normal distribution. And this is a key cumulative distribution function, which eventually ends with 1. So this is about normal distribution. So if I have to talk about few property, so there is no skewness. Basically, skewness is if you got slight tail longer tails in the either of the zones, whether negative or positive. So there is no skewness in the normal distribution, and kurtosis is 3. So basically when we say kurtosis, I'll make separate videos for skewness and kurtosis. So when we talk about kurtosis, it is a basically a peakness of the curve. So if you see that this normal distribution has kurtosis of 3, so it is not really I mean you will see this to be a normal. So if I have to give the some example which has highly peaked, so if you see the peak of this is around 1.75. So if I have to tweak some data points, so if you see there is a high peakness, so this peak, this basically this zone has shifted upward in this data set, whereas it was very normal in this. So for kurtosis, I will make a separate video where I'll cover the leptokurtic, mesokurtic, and platykurtic. So I'll cover these 3 in that video. But for normal distribution, just remember that kurtosis is 3, and mean, median, and mode are equal. So your average, your median, and mode are equal in the normal distribution. So this was about normal distribution. Stay connected with the channel, and if you like this video, yeah, this is one of the important point that you are in a normal distribution. Your 68% of the data lies between one standard deviation, and 95, approximately 95% of the data lies between two standard deviations. So we already touched upon the Excel. So if you like the video, please do comment if there are any feedbacks. If you want me to take any more topics on normal distribution itself, and please do share with your peers. Stay connected with the channel, and once again, thank you for watching.